In this video, we'll talk about how to solve rational equations, and there's plenty of methods to utilize here. So we'll just kind of walk through a few different possibilities. So I think the best way to go through these is just start with an example. We know enough about solving equations to kind of piece some of these together. So hypothetically, if I wanted to solve 1 over x plus 1 equals 7, well, in order to kind of make this a little more workable, I could multiply both sides by x plus 1, meaning that 1 would then equal 7 times x plus 1. And so long as I'm careful with the parentheses, I can do that. Basically, I'm cross-multiplying, I guess, is a way of thinking about it as well. So then, in this case, 1 would equal 7x plus 7, and then we can subtract the 7. So we get negative 6 equals 7x, so then x would equal negative 6/7. And that would be one solution there. So this can work. If it's just a simple expression like this, we can just multiply by whatever the denominator is to eliminate the fraction. That's one possible method. However, that doesn't always work as they get more complicated, and we'll see that here in our next example. So let's talk about a different example. I have 1 over x plus 2 equals 1 over x plus 3. Well, let's attempt to solve this thing. Let's give it a whirl. If this was like a proportion, we could totally cross-multiply, and we still can. So we could say 1 times x plus 3. Now I'm doing this to kind of just draw emphasis. If this was anything but a 1, I'd have to distribute through. And that equals 1 times x plus 2. So then this turns into, well, x plus 3 equals x plus 2. We'll subtract the x's. 3 does not equal 2, therefore there's no solution here. So like many of the one of the cases before is you can have no solution or you could have infinite solutions. However, if you have something like this where it's set up more like a proportion, you can still cross-multiply. You can still go through all those motions. They're still totally applicable. And again, we have the possibility that they might not always work. Or I guess that will always work, but there is one more method here that might be useful as they get a little more complex. So let's look at this example. 3 over x plus 4 equals 1 over x plus 1 minus 2 over x plus 4. So this one's a little different. I can't just jump to the cross multiplication because I have the subtraction to worry about here. So I think our first step is going to have to be, let's make this one fraction. So essentially we're going to do the subtraction. So I'm going to leave the left side as 3 over x plus 4 for now. And then what we're going to do is we're going to say, okay, well, I can multiply this one over here by x plus 1 over x plus 1. And then I can multiply the one on the right, or the one on the left by x plus 4 over x plus 4. That could work. Okay. So then what we can do is say, all right, well, we have x plus 4, because 1 times x plus 4 is x plus 4, minus 2 times x plus 1 is divided by x plus 1 times x plus 4. So now I've made it more complicated, it seems like. I've made it uglier. However, it's going to get a little bit easier. So now we could potentially cross-multiply. We could do that, but then we're going to have a quadratic, and then we're going to have a whole mess of things to deal with here. So another way we could look at this, and this kind of stems from the idea over here, if I have x over 7 is equal to 9 over 7, well, I think then we could deduce x has to be 9. We can, in essence, drop the denominators, right? If I can make these two denominators the same, then I can set the numerators equal to each other, and it might save me some work, and I think it really will here, because I don't have to change this one up here. That's already set. If I'm looking at this, if we're trying to find a common denominator between this blue fraction and this red fraction, well, the only thing that's missing is the x plus 1 on the red fraction. So I could say, okay, 3 times x plus 1 over x plus 1 times x plus 4 is equal to x plus 4. I'm going to go ahead and distribute this 2 in now just to get it done. So minus 2x minus 2 all over x plus 1 times x plus 4. Now, I wrote this step out for emphasis here, just to kind of draw attention to it. If you wanted to go ahead and jump to the next step, which would be where we would essentially drop these denominators, you totally could, because we would know they'd be the same. So we can say, all right, I'm going to go ahead and distribute this 3 in. 3x plus 3 is equal to, and I'm going to go ahead and combine some like terms, negative x plus 2. And at this point, this equation is much, much easier to solve for. So let's go ahead and do that. Let's finish this off. So we'll add x to both sides. So 4x plus 3 is going to equal 2. Subtract the 3. 4x is going to equal negative 1. Therefore, x is going to be negative 1/4. And that would be a solution. So you don't always have to cross multiply, and sometimes it can save you some work to not cross multiply, like we did up here. We found a common denominator, and then in essence we can drop the denominators. So if you wanted to make the jump once you've found your common denominator from this to this, you totally could, this being right here. The 3x plus 3 equals negative x plus 2. I drew it out here just to kind of draw emphasis to it, and just to really show you that, yeah, we can drop the denominators. It's not so much that they go away, it's just it's part of like an identity in mathematics. So this is another option. This is kind of a third method to solving rational equations. When you're going through, just try and think, okay, what's the simplest possible way to do this? And usually that will guide you through. Most of the time you can just cross multiply and go for it, but every now and then you'll have something like this where you'll be dealing with a quadratic or even a cubic term, which makes things much more difficult.